a mass spring system oscillates with time period T1. Another identical spring is connected in parallel with the first spring as shown. The mass is unchanged. The time period of the oscillation for the two-spring system is T2. What is the ratio T2 to T1? We know that period for mass spring system is 2 pi multiplied by square root of m over k, where k is spring constant. And let's consider when there are two identical, or in general it may be not identical, springs in a series and two in parallel. What is the resultant spring constant for given combination? So when two springs are in a series, the resultant spring constant can be found as 1 over k total is 1 over k1 plus 1 over k2. And when two springs are identical, it becomes just the value for spring constant for one divided by number of springs. And when two springs are in parallel, the resultant spring constant is just the sum. And you may notice that it's very similar to resistors, but vice versa. For springs in series, it's the same as for resistance over resistors in parallel, and for springs in parallel, it's the same as for resistors in series. So for two spring system, the resultant spring constant, it's just the sum, it's 2k, and mass is the same, hence period, it's T1, it's T2, becomes 2 pi square root of m over 2k. Hence the required ratio becomes, definitely 2 pi cancels and square root of m also cancels, and we get that T1 it's, or T2 it's 1 over square root of 2k, T2, and divided by T1, and T1 is 1 over root of k, and hence we can see that it's 1 over root of 2. So it's B. And that's all for this question.